So I'm going to turn this over to Dr. Roberto Sainz. Bob is a professor at animal science at UC Davis. Teaches beef and sheep production, does research in growth and development and ruminant nutrition, does a lot of international work. And I'm going to give this to you as soon as I get here, and we'll get the slides changed.
How are we doing, Ark? Is that working? Well, good morning. I'm glad to see all of you here and listen to some of the stuff we've been doing.
What's the name of your...
I think it's that one, down below.
Field Day 208?
Try that one. Yeah. Okay, so this study, Jim talked about some of the supplementation we did with the cow herd over a number of, I think it was actually more like 7 years, Jim, in total.
5, but yeah.
And that project was focused a lot on grazing management, you know, how we did the stocking, and whether we could use body condition score as a clue for when and how to supplement the cows. The work I'm going to describe here is from the last 3 years of research we've done with supplementation here, in this case with replacement heifers. And, you know, on the station, always have difficulty getting replacement heifers up to breeding size, you know, so they can calve as 2-year-olds. And it just has to do with our grazing season and the amount and quality of the feed. So we've always been looking, you know, we've had to supplement or use our irrigated pastures to help those heifers get a little better gain. And the study we started here was trying to find a cheaper way to do that than the standard supplements we were using. Just to I guess everybody here knows that we're in a Mediterranean climate, which means hot, dry summers, cool, wet winters. Most of the forages we have in this part of the country are annuals. They'll germinate with the first rains, not grow very much during the winter. Right now they should be growing. If we had rain, they would be, I suppose. But by summertime, those plants are dead, and we have to go through summer and fall with basically dead, mature standing forage. Okay, and you know, we've learned how to manage that pretty well, except that, you know, the quality of this material is pretty bad. I mean, this shows summer range here. You can tell the difference the water makes. That's the irrigated part. This is not. Okay, another view of the same thing. So it looks different here throughout the different seasons. Okay, but this is the forage that we really have to work with for a good part of the year here. Okay, and actually this is in pretty good shape, isn't it, Justin? It's not always that good. Okay, so the problem with these mature forages is as the plant matures, the cell walls get thicker and more lignified, so there's a lot of fiber and not a lot of nutrients. Okay, now the cattle can digest that because they're microbial action in the rumen. But in order to do that, we have to feed the bugs. We have to feed the rumen bacteria so that they can then feed the cow. All right? And what the rumen bacteria need, they need protein or nitrogen and sulfur and, you know, some of the minerals and cofactors. So we have to make sure that the bacteria get that so that they can then do their job and break down this plant fiber. Okay? So the objectives of this were to compare gains by weaned heifer calves, grazing, that kind of forage, but using different kinds of supplements. Okay. We also wanted to look at what happened to forage dry matter and digestion. Okay. And I've learned years ago that unless we actually do a cost-benefit kind of analysis, I can't stand up here and talk about it to you guys, because that's the first question that always comes up: is what does it cost? Okay. So anyway, we've taken samples of our forage in the summer, and it looks something like this. Crude protein down about 5.5. And just for reference, the bacteria in the rumen, if you want to maintain a healthy bacterial population, they need about 7% crude protein. Okay, if the feed has less than 7%, the bacteria will be deficient, and then they can't grow. And if they don't grow, they can't digest the fiber. Okay, so we're below that level, and late in the fall it would get down to about 3. Previous work has done that it would get even lower. Okay, the TDN is fairly low, lots of fiber. This is fiber, and kind of deficient in some of the minerals too. Things like the copper and selenium, as we know, of course, are deficient as well. So, our normal practice here has been to use these commercial molasses-based tub supplements. You've probably all used those. They're pretty handy because you can put them out and kind of forget about them. They're about 30% crude protein, some mineral supplements and some vitamins as well. And we thought that we could do better. When we looked at the quality of the forage and what the requirements of the animals were, as Jim showed you, we thought we could do better. So we formulated a dry range mix. Instead of 30, it's 54% crude protein, and pure soybean meal is about 40%. So the only way you can get up to 54 is using a fair bit of urea, okay, non-protein nitrogen in there, and balancing it out for things like phosphorus and some of the macro and micro minerals as well. We also we used this supplement in 2005 and 2006. In 2007, we also formulated our own homemade tubs, okay? Because the tubs are good, but they're really expensive, and so we decided to make our own. And we zooped up the protein up to 64%, okay, and then balanced out the minerals as well. So in 2005, these were the feeders we were using because that's what we had on the station, and they're missile boxes, I think, right? They're military surplus missile boxes, and they work pretty good. You can, the cattle will eat out of them, but it's a lot of labor. We had to. I basically put a student up here for the summer and said, okay, you're going to go feed the cattle every day to do the experiment. But that turned out to be very labor intensive. So the following year, we devised our own. Let me go through this first. Anyway, so we started out with cattle at about 260 kilos, which is about 550 pounds, 5.5 weight heifers. Okay, kept them from June through to September. Okay, on the pasture with the supplements. Our daily gain, this is about 1/4 pound. That's about 1/2 pound. So we doubled the rate of gain on those heifers. Okay, using our supplement, the UCD supplement. Okay, so we're pretty happy about that. When we look at the cost of those things, our supplement was cheaper, and they ate about half as much. Okay, so we doubled the gain for about 1/3 of the cost. So we said, hey, not bad. There might be something to this animal science business after all. So we decided to repeat the study, but like I said, it was very labor intensive to feed every day. So we took, and I'm not sure what these are, maybe a different kind of missile, like a stinger box or something, I don't know. We use a lot of military surplus stuff here. So anyway, we fabricated these self-feeders, and you get the picture. I mean, this is not high-tech science we're talking about here. We're really trying to figure out something that you can do cheap at home and save some money, maybe make some. Okay, so we basically took these military surplus casings here, built an angle iron frame and some plywood there with a hopper, then so that you could put the feed in maybe once a week or maybe once every couple weeks. All right, and those work pretty well. There's an opening down at the bottom of this plywood, so the feed just feeds falls out into here. And the cattle tend to like it. So the second year, same exact experiment, was with the commercial tubs and the dry range. The heifers were a little bit lighter, but our gains probably had a worse feed year. Gains were basically 0 on the commercial tub, which is actually pretty good because normally they'd be losing weight this time of the year. But about 1/2 pound again with the UCD supplement. Okay, and the cost in this case, they ate less of the commercial tub this year, so the cost was about the same. But the gains were so much better that it still pencils out as really good. So when we combine the 2 years of data, okay, we wind up with cattle about between 5 and a 5.5 weight cattle, gaining over the summer, and a huge increase in the performance of those cattle. They were gaining about half a pound on that dry range using our supplement. Okay, so this was all very encouraging stuff. We decided to do a third year of the research, but by then we didn't want to use the commercial tubs anymore because they clearly were not doing very much for us. And we decided to try to make our own tubs, because even though those self-feeders work pretty good, you know, you still get a little bit of caking and some bridging inside the hopper, and so you have to go in there once in a while and knock the feed down. And so the tubs are handy because you put them out and basically forget about them and just check and replace them when they're empty. So we decided to make our own. We figured we could do it for lower cost. We also did a digestion study down at Davis because we wanted to look at the digestibility and the intake of those things. So anyway, this is how we made the molasses tubs. All right, we use basically a cement mixer. Okay, like if you're expecting high-tech, you know, science, this is not it. Okay, try to do something fairly practical. Cement mixer. We formulated a dry mix with a canola meal and our minerals and dry ingredients. Okay. Add the molasses. It makes a mess in the mixer. Okay. I mean, I'm not going to lie to you. It's kind of a hassle, but you can mix it up and make this goop. And then we poured it into the plastic tubs that we had. We've got lots of empty plastic tubs, and so we poured it in there. You need to make it set. It's kind of like making Jell-O, okay? And the way we made it set was we added Portland cement, okay? Just a little bit, okay? Just a little, you know, just a little bit, but it makes it set up. Actually, the first time we added a little too much, and the tubs are pretty hard. In fact, after lunch we're going to go take a look at these tubs, and I think the one we brought up is one of the original ones that's really hard. The cattle go at it, but man, they got to work really hard to lick these things down. But we played with the mix a little bit. We finally got it to the right consistency, and it works fine. Okay, this is what they look like. And so for the third year, then we only compared our tub with our dry range supplement that we'd already been using for a couple of years. And even though there's a numerical difference here, it's really not nearly as large as we had with the previous tubs. Okay, and so I think the commercial tubs at 30%, which is the highest protein value you can get in the tub, they're really not high enough. Okay, because the forage is bad enough that we need a higher protein value. Once we zooped up the protein value with our tubs, it worked a lot better. Okay, and the cost of that was even better than our dry supplement. All right. So when I took and combined all 3 years of data here, and we then compare the commercial tub with our dry supplement with the tub, and you can see in terms of the average daily gains, this is about a fifth of a pound here. 2/3 of a pound, about the same thing for our homemade supplements. The intake's not very different, but the cost quite a bit cheaper for the supplements we formulated and made ourselves. Okay. So I'll go very quickly through our digestion metabolism studies because I'm running out of time. We took 18 steer calves. We had controls that were fed and they were fed wheat straw. The reason we use wheat straw, it's a low quality forage that's actually not too different from what our range grass is. Okay, and the controls only got a trace mineral salt. Then we had our tub and dry supplement. By doing this on campus were able to measure how much of each, how much straw they ate and how much supplement they ate. And we also could do a collection of feces and urine so we can measure the digestion of the stuff. This is our feeding barn where we can do individual feeding. This is basically what the straw looked like. This is our collection apparatus. I mean, the animal sits in this cage. We actually fabricated a rubber funnel to collect all the urine. Okay, because if we analyze the urine, we can then estimate how much microbial protein was synthesized in the rumen. Okay, from the metabolites. And we can also do a fecal collection. That's one of our students doing the fecal collection, so we can measure the digestion of the straw. Okay? Thank goodness for students. God bless them, every one of them. And so, on that wheat straw, as we'd expect, the steer calves lost about half a pound. This is kilos, but that's lost about half a pound a day. With the supplements, they basically broke even. Okay, so we didn't get any gain on them, but they didn't lose weight like the unsupplemented ones did. In terms of their intakes, the controls ate about 3.5, about 8 pounds of straw. That increased by about a pound when the animals were supplemented. So we gave them the straw plus the supplement, and eating the supplement allowed them to eat more of the straw, okay, and get more of the energy from that. Why? Because the bugs are healthier, the bacteria are growing, they're digesting the straw, and if they can digest it, they can eat more. Okay? So basically, just the bottom line, I think we've shown that calves definitely can benefit from a high protein and mineral supplement. Our dry supplement was very superior, 4 times as good as the commercial tub, and the cost was about 40% less. So I think we really got a winner with this supplementation strategy, and I expect we'll be seeing a lot more of that. You can construct a feeder, and I'm sure probably you guys can design a better one than what we did, and make it at home so you don't have to feed every day, or you can go with the tub scenario, and that worked pretty well as well. Okay, we're still analyzing our samples to figure out what happened in terms of digestibility and ruminal microbial protein. So I really want to thank a lot of the students and people that worked on this project. The first student was a Brazilian fellow that was here with me, Rafael, and he really came up and stayed here the first summer and really got the ball rolling with this project. These very high urea levels are commonly used in Brazil. Okay, this is what they do in their dry season. They feed a lot of urea because it's cheap and supplies the protein they need. And then a bunch of other students that have worked on this: Gustavo Cruz, who's here, Luis Felipe and Luis Roberto, also Brazilians. Dan Myers, our staff person, and the other people at UCD. I also want to give a special thanks to Marita Rana and the Gilbert Company, because they helped us out when we were formulating the diets, and they actually made our dry range mix and the premix for the tubs. So they contributed intellectually, they contributed making the stuff for us, and actually supported the research financially as well. So. And of course the research center. So. Okay, I'm going to have